Good day, everyone. Welcome to another video tutorial in time rates this time for Maxima Minima. So we have one problem here for Maxima Minima. We have an airplane flying horizontally at an altitude of 1 kilometer, passes directly over an observer. If the constant speed of the plane is 240 kph, how fast is its distance from the observer, increasing 30 seconds later? So as you would notice in here in our figure, we can draw the figure by simply stating that this is the airplane, this is the location, initial location of the airplane, and it has an altitude of 1 kilometer from the observer. And take note that this is the observer, the position of the observer. If the constant speed of the plane is given, so you have 240 kilometers per hour, the question is, how fast is its distance from the observer, increasing 30 seconds later? So if you would see, this is the position of the plane after 30 seconds. Let's say that is P prime. This is the initial position of the plane, sir. This is the initial position of the plane. Okay. So the distance from the initial position to the position of the plane after 30 seconds or 30 seconds later, let us call that as x. And then the distance from the observer to the plane after 30 seconds, let's call that as y. So from here, from P prime up to the position or location of the observer is y. The distance from P to P prime, which is the initial position to the final position of the plane, is P prime. And then of course you have here the altitude, which is the distance from the initial position of the plane up to the observer. And you would notice that we can create here a right triangle. Okay, so we have here a right triangle by connecting those positions or those points. And because we have a right triangle here, we can make use of Pythagorean theorem. Using the Pythagorean theorem, we can now solve for the value of x and y. So if we are going to set y squared is equals to x squared plus 1 squared. If you have a right triangle, remember, if you have a right triangle, say this is A and this is B, and we've got a right triangle, and then this is C. If you would want to determine any of the sides given two sides, you can make use of the Pythagorean theorem by simply stating that C squared is equals to A squared plus B squared. So we have here C squared plus C squared is equals to A squared plus B squared. So if you would notice, based on our figure previously, which I have shown you, you would notice that we have 1 kilometer here for the altitude, and then we don't know the value of x, and we also don't know the value of y. This is the position of the observer. This is the initial position of the plane. And this one is the final position of the plane. So take note that the velocity of the plane flying directly over the observer horizontally with a constant speed is 240 kph. So that means the change in distance relative to the horizontal position with respect to time, let's say that is dx dt, is equals to 240 kilometers per hour. Because the speed of the plane is 240 kilometers per hour, we can say that the distance x with respect to time is, or the change in x with respect to time is equals to 240 kph. And take note that the time given is 30 seconds. So we have 30 seconds here. And if we are going to convert this to hour, that is roughly equivalent to 1 over 120 hour. That is for every 1 hour, we have 3,600 seconds. So going back here in our equation using the Pythagorean theorem, y squared is equals to x squared plus 1 squared. We can now derive or differentiate both sides of the equation. So you have 2y, and that the change in y is with respect to x. The change in y is with respect to x. Remember that whenever x would increase, the value of y would also increase. So the change in time in y, the distance y, is dependent on the change in x. So we have 2y is equal 2y dy dx by getting the differential of y squared is equals to the derivatives of 2x is x squared is 2x, and this time the change in x is with respect to time. Okay, so the change in x relative to time, plus of course you have 1 kilometer, which is equals to squared, is the derivative of a constant is equals to 0. So that is why you have 1 squared will be equals to 0. So we can now rewrite this as this equation. So if you can see, we can cancel 2 here. So y dy dx is equals to x dx dt. And if you are going to express the value of dy dx, meaning the change in the distance y with respect to the change in x, is equals to x over y multiplied by the change in x with respect to the change in time. So according to our problem, at after 30 seconds, okay, which is equivalent to 1 over 20 hours, that is the value for the time. And you would notice that the value of x can be determined using the formula for speed. Speed is simply equals to distance over time. And therefore, if you would want to determine the distance, you can just say distance is equals to speed times time. So the distance is equals to speed times time. So if we are going to determine the value of x, because the rate or the speed in horizontal position of the plane is 240 kilometers per hour. So we can just multiply 240 kilometers per hour by the value of time, which is equals to 1 over 120 hour. And that would mean the value of x is equals to 2, the unit of which is in kilometers. So we can make use of the value of x here to determine the value of y. Y squared is equals to x squared, that is 2 kilometers, plus 1 squared. And that simply is equals to the value of y is equals to the square root of 5. That is from y is equals to the square root of 4 plus 1. So that's why you have the value of y is equals to the square root of 5. So if we are going to determine dx over dt, or that is 240 kilometers per hour, and if we would want to determine dy over dt, or the change in y position with respect to time, that is simply equals to x, which is 2 kilometers, and then the value for y, which is square root of 5, and then you multiply it by dx over dt, which is equals to 240 kilometers per hour, then that would mean dy over dt is equals to 214.66 unit kph, kilometer per hour. And this will be our answer to the problem. The answer is 214.66 kilometer per hour. That's it for today. Thank you very much for watching and listening. See you again on my next video tutorial. I hope you have learned something from it. Once again, this is Engineer Ramirez. Thank you very much. See you.